So in these sections, please note, we're combining two sections and you are only learning the power property. You are not learning all the properties. We used to teach all the properties, but we don't anymore. So you're only learning the power properties. In future classes, you'll learn other properties, but for this case, we're just mixing these properties in these sections together. So this is what the power property says. It says if I have a log and the x is raised to some power, I can bring that power in front of the log, and it's the same thing. So it says the log of a number raised to a power is the product of the power and the log of the number. Okay, you don't have to memorize all those words. You just need to know, hey, if it's raised to a power, you can bring it out in the front. So let's take a look at some examples. First example, log base 2 of x raised to the 5th. That's the same as saying 5 log base 2 x. Alright, here's this one. Log base 10 of the cube root of x. Well, the cube root of x is the same as saying x to the 1/3. Remember that we learned that back a few sections ago? And so I can bring that 1/3 out, and that becomes 1/3 log base 10 of x. Here is another example, and this one is expand and find your a and your b. So in the book, what you can do is you can take this problem and you want to find out what a is and what b is. So when it says find a, b, it just wants you to rewrite this log using the power property and tell what is the number in front and what is the number that is there that's being logged. So log base 2 of the 8th root of x. That's the same as saying log base 2 of x to the 1/8, because we used our property before that allows you to turn that into an exponent. Then I use my power property, bring that out in the front, 1/8 log base 2 of x. So what is the a value here? Well, it's the 1/8. That's what's in front of the log. What is my b value here? It is the x. And so when you come across those problems, don't make them harder than they seem. All you're doing is changing that into having the exponent down in front and then writing what that exponent was in front and writing what you're taking the log of. Something to note real quick, if I don't list what the log is, it means it's base 10. So now I'm going to look at some solving problems, exponential equations, and whenever I have an x up in the exponent and it says solve, what I can do is take the log of both sides. So I take the log of this side, I take the log of that side, that keeps the equation balanced. Then I'm going to use my power rule, which says I can bring that x down in front. So I have x log of 2 equals log of 6. Then my goal is to get x all by itself. So I'm going to solve for x by dividing this side by log of 2, but then I need to divide that side by log of 2. And then I take this and I stick it in my calculator. Log of 6 divided by log of 2, and you get approximately this. You should try and do this in your calculator so that you understand how to use logs and make sure that you can get to the same answer. And here's another example where I have a negative x. So again, my x is the exponent, and if I'm wanting to solve this, I'm going to go ahead and take the log of both sides. Then I can use the power rule and bring that log out in front. But if I bring that log out in front, then what I want to do is divide both sides by log 2, and also either divide by -1 or multiply both sides by -1. So you can stick that in your calculator to get your answer. Okay, then one last thing to notice. If you were to see something like this on the test where it says log of 12,200, you would just stick that in your calculator. This is not saying like an x and a y value, so don't get confused on that with previous things. This just means 12,200. I don't know if that problem's still on the test anymore, but in the past it's messed students up on quizzes and tests. It just means stick that number into your calculator and take the log.